Good morning, students. Yesterday we started that KW, no? Ionic product of water. You read that what is that ionic product of water? We represent it with the symbol KW. So write today's date, write heading ionic product of water. So this ionic product of water, yesterday do we discuss this? We represent with the symbol of water KW. So for continuity, see once again I am reminding this ionic product of water is simple. Water gets ionized into water H plus ion and OH minus ion. Correct? And to this when we apply equilibrium constant, that is K. So equilibrium constant, yesterday we discussed, it is the product concentration by reactant concentration. Product is what? H plus ion into OH minus ion, concentration of hydroxyl ion upon what? Concentration of water. This is what yesterday we wrote, correct? Where K is called equilibrium constant and water is a constant because water ionizes to very less extent. Now I bring this water to the left side. So K is a constant, water is a constant. Then what should I write? H plus ion concentration into OH minus ion concentration. And this K is constant, water is a constant, and that we wrote in terms of KW. So therefore KW is nothing but it is the product of hydronium ion concentration and hydroxyl ion concentration at a given temperature. This is what important. So what is KW if they define, what we define for KW, it is the product of H plus ion concentration and OH minus ion concentration at a given temperature. This is known as ionic product of water. Understood? And at 25 degrees centigrade, do we discuss that at 25 degrees centigrade, the value will be fixed. What is the concentration of H plus ion? 10 power minus 7 mole per liter. And concentration of hydroxyl ion concentration will also be 10 power minus 7 mole per liter. So what will be the value of KW? The value of KW will be product of these two, no? So that is 10 power minus 7 into 10 power minus 7. That comes 10 power minus 14 mole square per liter square. This will be the value of KW. So this is what understood. KW is nothing but it is the product of H plus ion concentration into hydroxyl ion concentration. Clear, understood all of it? So this is what we discussed yesterday. And do we discuss what will be the effect of temperature on KW? So as temperature increases, KW value what happens? Increases. This is at 25 degrees Celsius, no? At 25 degrees centigrade, the value of KW will be 1 into 10 power minus 14 mole square per liter square. But with increase in temperature, what happens? More ionization of water takes place. As ionization of water takes place, what happens? More H plus ions will be produced. So KW value what happens? Increases. Copied this all of you. Understood all of you? Simple, no? So in this relation, we get numericals in exam. And write next point. As temperature increases, what is the effect of temperature on KW? So with increase in temperature, KW value what happens? Increases. So in assertion reasoning, they can ask in exam, in JEE mains and NEET, assertion reasoning, they give assertion statement and reason one statement. So as in temperature increases, KW value increases. What is the reason KW value is increasing? So since temperature increases, ionization of water increases. With increase in temperature, ionization of water increases. So therefore Kw value what happens? Increase. For example, yesterday I given at 90 degrees centigrade. Suppose if I am taking at 90 degrees Celsius, what will be the value of Kwc? Its value is 1 into 10 power minus 12 mole square per liter square. So what is happening, as within 25 degree we wrote 10 power minus 14 we wrote. Now 10 power minus 14 is bigger or 10 power minus 12 is bigger? So this value is bigger, no? So what happened to the Kw value with increase in temperature? Kw value is increasing due to ionization of water increases. Clear? That's all about Kw. Now, what are the applications of Kw? Copied all of you, following everyone. Simple, no? So, what is the effect of temperature if they ask? With increase in temperature, Kw value increases. What is the reason to increase if they say? Ionization of water increases. Understood, students? Right. Now, the right one, applications of Kw. Now, what are the applications of Kw? Do we discuss this yesterday? So in the applications of KWC, if I know any one concentration, suppose I am knowing if H plus ion concentration is known, then we can find out what OH minus ion concentration. We can find OH minus ion concentration. That means any one concentration, if you know, either H plus ion you know, or OH minus ion you can know, you can find out the other one. So see how do we done any question on this? Write one question. If H plus ion concentration is 10 power minus 8 molar, then find its OH minus ion concentration. So see the question, see concentration of H plus ion given, and what we have to find concentration of OH minus. So what is the relation? Kwo is equal to product of what? H plus ion concentration into OH minus ion. Since when they don't mention temperature, you go by 25 degrees Celsius. Here he has not mentioned temperature. So when he doesn't mention temperature, assume that it is at 25. So what is the value of Kw at 25, students? That is 10 power minus 14. So this I have to take 10 power minus 14. Following? So this H plus ion concentration I have to take 10 power minus 8, and what we have to find? OH minus ion concentration we have to find. Then what will be OH minus ion concentration? 10 power minus 14 upon 10 power minus 8. So minus 8 bring numerator. So when you bring minus 8, that becomes 10 power plus 8. So 14 minus 8 comes almost 10 power minus 6. This will be the concentration, and unit you have to mention mole per liter. So concentration is mole per liter, or you can write molarity. Either you can write mole per liter or molarity. So understood? So if any one is known, either OH minus ion I am knowing, I can find out H plus ion. So is it an application or not? Understood, students? Clear, no? So H plus ion concentration is given, and I am asking to find OH minus ion concentration. So what we take? Kw value, when they don't mention temperature, go by 25 degrees Celsius. So 25 degrees centigrade, Kw value is 10 power minus 14. Clear, understood? Right. Now write next application 2. Now what is that application 2? Do we read yesterday? We can know the nature of solution. Means whether the solution is acidic or basic or neutral. So application 2, we can find out what, students? Nature of solution we can find. How? Do you know in 10th standard pH concept? Might be in 10th standard you may heard pH, no? So see how, suppose if H plus ion concentration is coming more than hydroxyl ion concentration, means what does it mean? The solution is acidic. Why? Because hydronium ion concentration is more. So what will be nature of solution, students? Nature of solution will be acidic. So what is acidic we discuss in the coming session. pH will be less than 7. So how will be pH for acidic, students? Less than 7. If it is what solution? Acidic solution. Now are we knowing the nature of solution or not? Or else what the another condition we get, students? Or we can get a condition of H plus ion concentration comes less, hydroxyl ion concentration is coming more. That means what does it mean? Its nature is basic. So what is the nature of the solution? If they ask, the nature of solution will be basic. Basic means what should be the pH, students? pH should be greater than 7. So pH of solution should be greater than 7. And what is the another condition we get? See, there is another possibility. Sometimes the H plus ion concentration may be equal to what? Hydroxyl ion concentration. In this case, both are equal means what does it mean? Its nature is neutral. Neutral means what will be the pH? pH value will be equal to 7. So, are we knowing the nature of solution from Kw value or not? So, this is the application 2. Clear, understood? So, these are the two natures. One is acidic, basic. If it is acidic, pH will be less than 7. If it is basic, pH will be greater than 7. If it is neutral, pH will be equal to 7. Clear? So, write one question on relation with pH, on relation with Kw. Write one question, say, copied all of you. This question you write at 90 degrees Celsius. At 90 degrees Celsius, Kw value is 1 into 10 power minus 12 m square. Then find its H plus ion concentration. Find its hydronium ion concentration. So in exam questions related with Kw, they ask the concept of Kw. See, at 90 degrees Celsius, Kw value given to you 1 into 10 power minus 12. And you have to find out what is the concentration of H plus ion. Now, still think, student, how you approach. So as Kw value is given 10 power minus 12, what we equate with H plus ion concentration into OH minus ion concentration. No? Now at a given temperature, these two will remain same. That means H plus ion concentration will be equal to OH minus ion concentration. Then can I write 1 into 10 power minus 12 is equal to H plus ion square. Since concentration of these two should remain constant, no, at a given temperature. So these two I am equalizing, though can I write H plus ion square? Now remove the square, students. So when you remove the square, what it becomes? It comes to root over 10 power minus 12, no? Correct? When I am removing the square, what it comes to? Root over 10 power minus 12. Now removing the root, what will be the H plus ion concentration? H plus ion concentration will be 10 power minus 6. Units will be what? Molar. So understood, this is how we are finding H plus ion concentration at 90 degrees Celsius. So this Kw concept completed. Works understood all of you. Till now Kw means what are the applications we learned. Now I have to teach next pH concept. Right heading pH concept. Copy them all of you. Following everyone. So next heading write pH concept. pH concept. See, very important. In later we study in equilibrium chapter. As you know, this is a bridge course. Later when we come into equilibrium chapter, we detailedly study pH. A pH concept was introduced by Sorensen. Who introduced this concept? See, Sorensen introduced it. What is the person name? Sorensen. Then what is pH, student? pH is nothing but negative logarithm of H plus ion concentration. What is the definition for pH? Do you have in 10th standard, students? What we define for pH? It is negative logarithm. It is negative logarithm of H plus ion concentration at a given temperature. at a given temperature. At a given temperature. Negative logarithm of H plus ion concentration. So the negative logarithm of H plus ion concentration is called pH concept. Understood? So mathematically how we write, student? pH is equal to minus log of H plus ion concentration. See, this is how mathematical representation of pH. The negative logarithm of H plus ion concentration is called pH. It doesn't mean that you should apply only for H plus. Any constant you can apply. Suppose if I am writing for POH. Now tell me what should I write, student? POH value will be equal to minus log of OH minus ion. So when I am applying POH, what should I write? Minus log of OH minus. What is OH minus? Hydroxyl ion concentration. So any constant we can apply. Generally we apply for pH. For generally we can even apply for any constant like pH, POH, and you know pKa. So tell me how we get pKa. pKa is what? What is Ka? Dissociation constant for an acid. So when I write pKa, what should I write, student? Minus log of Ka. See, any constant we can apply, but generally we take for pH. Then what is Ka? Dissociation constant for acid. And you know for base we write dissociation constant for base. If I write for pKb, what should I write? pKb is equal to minus log of Kb. See, minus log of Kb. This is for dissociation constant for base. And just now we studied no Kw. If I apply logarithm for Kw, what should I write? pKw. So pKw is equal to what we write, students? Minus log of Kw. So any constant we can apply. But generally we write it for what? pH. Understood? Copy this relation. This is pH is negative logarithm of H plus ion concentration. And if you want, write here what is Ka? Dissociation constant for acid. What is Kb? Dissociation constant for base. What is Kw? Ionic product of water. Understood, students? Here copied all of it. Simple understood. No? So pH is nothing but negative logarithm of H plus ion. But we can apply for any constant. Copied on. Now see, we wrote one relation no previously. What is that? Kw is equal to what we wrote? H plus ion concentration into OH minus ion is equal to Kw we wrote no. That is 10 power minus 14 we wrote. Now what we do? We apply logarithm on both sides. When we apply logarithm on both sides, tell me what should I write? Applying logarithm on both sides. So both the side we apply logarithm, then what should I write? Minus log of H plus ion minus log of OH minus ion is equal to 14 log 10 it comes. Log a power n means minus log of 10 power minus 14 students. Or I can write that as Kw. Understood? This can be written as Kw. Kw. This is Kw. Or I can write minus log Kw. Or what I can write? See, minus log of H plus ion concentration minus log of OH minus ion is equal to minus log Kw. Understood? Then this can be written what? Minus log of H plus is pH, no? So pH plus this can be written POH, no? This is equal to what, student? pKw. And this value will be how much? 14. Actually 10 log 10 power minus 14, what we write? Minus of minus plus. So this value will be equal to 14 provided temperature to be 25 degrees Celsius. So pH plus pOH value will be equal to how much? 14 provided temperature should be at 25 degrees centigrade. This is the relation between pH and pOH. And here students should know some basic maths. Log A into B form is there. How you write log A plus log B? Log A by B form it is. How you write log A minus log B? Log A power n form it is. How you write n log A? So generally these mathematic basic maths we get in calculation. Log A into B, log A by B, log A power n. So log A into B what we write? Log A plus log B. Log A by B what we write? Log A minus log B. Log A power n. N log A. So this, see, this is in the form of log A power n. So minus of minus plus 14 log 10. Log 10 value 1. Copied, and student you have to remember log 1 to log 10 value. In exam they don't provide log 1, log 2. See, log 1 value will be 0. Log 2 value will be 0.3010. Log 3 value will be 0.4771. Log 4 I can get double of log 2. Log 2 means log 4 what I can write? Log 2 square can I write? Log 2. 2 into 2. That means double of log 2. 0.6020. Log 5 you have to remember. Log 5 value will be 0.6989. Log 6 value we can get. How student? Log 2 plus log 3. Log 2 plus log 3 how much you get? 0.7781. Log 2 plus log 3. Getting idea? Log 2 into 3. Log A plus log A into B. For log 7 value you have to remember. Log 7 value will be 0.845 nearly. 0.845. And log 8 value we can get. How? Log 2 plus log 4 student. Log 2 plus log 4 means how much? 0.9030. Log 2 plus log 4, 0.9030. Understood. Log 9 we can get students. How we get log 9? Double of log 3. This double you take. 0.4771 plus 0.4771. 2, 14, 15, 9, 0.9542. 0.9542. Log 10 value given 1. So up to log 1 to log 10 there is no rule to provide in exam. Up to 10 you have to remember. Suppose log 25 you got, don't say I don't know. Log 5 into 5. Log 45 you got, log 4 into 9. 5 into 9. So these values from 1 to 10 you have to remember. completed all of. So clear now up here pH. What is pH? What are the values we wrote logarithm, and relation between pH and pOH is pH plus pOH value will be equal to 14, provided temperature to be 25 degrees Celsius. Copied all these values. Shall I proceed next? Right. Now see next see. Suppose pH of solution is given 2. Let the pH is 2. Then what will be its H plus ion concentration? Then H plus ion concentration will be 10 power minus 2. That means there is a relation when we take anti-log, H plus ion concentration is equal to 10 power minus pH. This is the relation. When pH is given, how you get hydronium ion concentration? H plus ion concentration is equal to 10 power minus pH. If pH of solution is 2, what will be H plus ion concentration? Means what you say, 10 power minus 2. Understood? Suppose pH of solution is 4. What will be its H plus ion concentration? 10 power minus 4. Same way, if OH minus ion to be written, how we write? OH minus ion concentration is equal to 10 power minus POH. Hydroxyl ion concentration is equal to 10 power minus POH. That means taking anti-log of pH, we get this relation. Understood, students? Copy this relation. And see here one important note. For every 1 unit increase in pH, for every 1 unit increase in pH, for every 1 unit increase in pH, hydronium ion concentration decreases by 10 times. What happens to hydronium ion concentration? Decreases by 10 times. I will show you how this decreases by 10 times. And converse. Converse means what? For every 1 unit decrease in pH, if you decrease pH by 1 unit, hydronium ion concentration increases by 10 times. Or for every 1 unit decrease in pH, the hydronium ion concentration increases by 10 times. Converse. If you are decreasing 1 unit, hydronium ion increases by 10 times. If I am increasing by 1 unit, hydronium ion concentration decreases by 10 times. Understood? For every 1 unit increase in pH, hydronium ion concentration increases by 1 unit, 10 times. Now, how this relation you can understand? Write one question in exam how they ask. Copy this. Understood, Amma? For every 1 unit, when you increase the pH by 1 unit, hydronium ion concentration decreases 10 times. Or for every 1 unit decrease in pH, what happens? Hydronium ion concentration increases by 10 times. For to understand this, write one question. Copied all of it. This is important. Copied. Now write one question on this. See, in exam how they ask, if pH of a solution is increased from 0 2 to 5. Then find the hydronium ion concentration. Now question, understand what he is saying. pH of solution is been increased from, initially pH was 2 and it has changed to pH 5. Then what will be its hydronium ion concentration? In option they give increases by 10 times, decreases by 10 times, increases by 100 times, or decreases by 100 times. So what option do you get? See, question you understood? So what is the initial pH, students? Initial pH is 2 as given. Means if pH is 2, what will be hydronium ion concentration? 10 power minus 2. No? Now it has been increased to 5 is saying. Means how many units we have increased? 5 minus 2, 3 units we have increased. So for this, what will be the hydronium ion concentration? 10 power minus 5. So for every 1 unit, it is decreasing. When for every 1 unit increase in pH, it decreases by 10 times. Now can you see how many times it has decreased? 1000 times it has decreased. 3 units we have decreased, no? So for every 1 unit, if it is decreasing by 10 times, for 3 units, what will be the decrease? So hydronium ion concentration decreases by how many times, students? 1000 times. Understood? Or if the same question, if I say pH of solution is changed from 5 to 2, I say. Previously I increased. Now what I did, I decreased. So if I am changing from 10 power minus 5 to 10 power minus 2, what will happen to hydronium ion concentration? In this case, it increases by how many times? 100 times. Understood concept? Clear for all? So for every 1 unit increase in pH, hydronium ion decreases by 10 times. For every 1 unit decrease in pH, hydronium ion concentration increases by 10 times. Clear, Amma? Copy this. So in exam point of view, they ask such type of questions. And concept is, I have to remember, for every unit, 1 unit increase in pH, hydronium ion concentration decreases by 10 times. Clear? Any doubt in this? No doubt, no? Everyone understood? Yes, I think so, everyone understood this. So this is what from question. Initially I asked from increasing from 2 to 5. And second part I have given, if instead of increasing, if they say decrease from 5 to 2, then it will increase by 100 times. For this will be the answer. For first part, this will be the answer. Understood? Now we go for next calculation of pH. Right, subheading calculation of pH. So in our syllabus in bridge course, they have given strong acid, strong base, pH calculation. Right, subheading calculation of pH. Right, calculation of pH. So in our bridge course, they mentioned for strong acid and strong base. Right here, pH calculation. One we discussed for strong acid. Then student, do you know what are the list of strong acid? I told you 6 acids are to be strong. And see here, I have to teach one more concept, Sorensen scale. There is one scale called Sorensen scale. Before going to calculation, you have to know what is the Sorensen scale. I told you, no, Sorensen has introduced the pH concept, so he has given one scale. Might be you know this in 10th standard. You remember it starts from 0 to 14. So do you heard this? The scale will be there. See when you see in textbooks. The upper one is hydronium ion concentration. This is hydronium ion. Below to this is pH. See here it is 10 power minus 7. Here it is 10 power minus 14. Here it is 10 power 0. Now the value in terms of pH will be, see here pH will be for this will be 0 and here pH will be 7. This is in terms of pH, students. This is upper one in terms of H plus ion concentration. So this is 14 it comes. So this scale is called Sorensen scale. Might be you know this below 7 will be all acidic. Above 7 will be basic. Exactly 7 will be neutral. So this idea you have to know. 7 will be what, students? Neutral. This will be neutral. And below 7 will be what, student? Below this will be acidic. And above 7 what, student? They are basic. This will be basic. And one more important, if it is strong acid, the value will be below 3. See, below 3 will all be strong acid. Above 3 will be weak acid. WA means weak acid. SA means strong acid. If it is strong acid, the pH will be below 3 below. And the same way bases will be 2 bases, strong base, weak base. If it is weak base, up to 10 will be weak base, students. WB means weak base. Beyond 10, 11, 12, there will be strong base. So we divide the scale into further into strong acid, weak base, strong base. This was the scale introduced by Sorensen. That means the Sorensen scale is applicable only at what temperature? 25 degrees Celsius. Following on. So this scale is called Sorensen scale. Completed. Now we go for calculation of pH. Right, subheading calculation of pH. So in exam they ask numericals on pH calculation. In our bridge course, as I told you, we have to study strong acid. One for strong acid, right? Now what are the strong acid list, student? There are only 6 acids to be strong. If you remember, I taught you in the introduction, 6 acids are only strong, like HCl, hydrochloric acid, hydrobromic acid, and hydroiodic acid, sulfuric acid, nitric acid, and perchloric acid. Only these 6 acids are strong. Rest of all are weak acids. Generally organic acids are all weak acids, like acetic acid, HCN, H2S. So for this we have to find pH in our syllabus. Right, heading pH calculation for strong acid. Copied all of it, right? Now I give you one question. See, for strong acid, when you are calculating what we require, student, H plus ion concentration is required, no? Is it right? To find the pH, what we require, student, H plus ion, no? So this H plus ion concentration is taken in terms of normality. See, one new word we are getting, normality. Normality we discussed in the next when we start the chapter. But remember, generally H plus ion is taken in terms of normality. Now there is a relation between normality and molarity. Molarity you people learned, no, last class. So sometimes in the problem they don't give normality, they give molarity. Then relation is normality is equal to molarity into valency factor. This is the relation. When we have to apply this relation in the question, if they don't give normality, if they give molarity, then student will get doubts, sir, what is this N factor? N factor or valency factor we say. This is number of replaceable H plus ions. Number of replaceable, as you know, acid will furnish what, student? H plus ion, no? So suppose I am taking sulfuric acid. Sulfuric acid will have how many replaceable hydrogen? 2. Then I have to multiply the given molarity with 2. If it is HCl, I have to take HCl is having how many replaceable hydrogen? 1. So I have to take N factor 1, valency factor 1. So it depends on the number of replaceable hydrogens. This is the relation. Then what is this normality? We discuss in the main chapter. Right now, see, if they don't give normality, if they give molarity, you have to bring the molarity into normality. Understood? Are you following? So this relation you copy it. The valency factor is number of replaceable H plus ions. Or we even say N factor. Understood? Write one question. Calculate the pH of 0.05 molar sulfuric acid solution. Now say question. What he wants to find pH for 0.05. See the value. This is given in molarity. Of what acid it is? Sulfuric acid. Now pH to get what we require? H plus ion concentration. No. So this H plus ion concentration is to be taken in terms of normality. Why? Because sulfuric acid is having how many replaceable hydrogens? 2. No. So that's the reason we should not consider, if you forget number of H plus ion, answer comes wrong. There are 2 replaceable. So what you do, this is not given in normality, as given molarity. So hence what is the relation? Normality is equal to molarity into valency factor. Molarity means these many moles, 0.05. But there are 2 replaceable hydrogens, no? So that's the reason you have to multiply this 0.05 into 2. That comes how much, student? 5 2s are 10. Means put decimal after 2 digits. Is it coming 0.1 or can I write 10 power minus 1? No. Now to this what we apply? pH. What is pH, student? We wrote just now, minus log of H plus ion concentration. Now this H plus ion what we got? Substitute in this. So what should be the answer? Minus log of 10 power minus 1. This is in the form of log a power n form. No. So when log n power log a power n form, minus of minus, what should I write? 1 log 10. So what is the value of log 10? Log 10 value is 1, no? So final answer will be 1. This will be the answer. That means is it coming below 3 or not? That's the reason it is a strong acid. Understood? So this is how we find pH. So to find pH, what we have to consider? Normality. Normality, if they don't give, molarity if they give, what you do? This molarity you have to convert it into valency factor. If they give directly normality, no need to convert. Clear? Understood? So to find pH, molarity is to be converted into normality. Why? Because there are 2 replaceable H plus ions. Completed. Now write one more question. Calculate the pH of 0.49 grams sulfuric acid present in 250 ml solution. 250 milliliter solution. Now see, in the question, see what you are asking to find pH he wants. pH he wants of mass given. How much mass given? 0.49 grams given. That is present in how many milliliter is saying? 200 milliliter is saying. Now tell me students, in order to find pH for this, what we require? H plus ion concentration, no? So this H plus ion concentration we have to take in terms of normality. Or you are familiar to find molarity, no? So molarity into valency factor you find out. Actually normality we don't know. So molarity into valency factor. Now can you find molarity, students? In the last class you are familiar, no? Molarity is nothing but number of moles by volume of solution in liters we learned, no? So tell me, do you know the mass? You know the volume. How you bring mole, student? Mole concept you studied, no? 0.49 is the mass. What is the molar mass of sulfuric acid? 98. Understood how we got 98? 2 plus 32 plus 64. Into volume is given not in milliliter. So I have to divide 250 by 1000. 1000 goes to numerator. Now this 0 cancel, 25 will cancel 100 by 4 times, and cancellation value 49 can cancel by 2 times, but decimal is there, this moving the decimal 2 times, this 2 will cancel 4 by 2. Now can I write 2 into 10 power minus 2, check whether you got this same concentration. This much we got in what? Molarity we got, but we convert that into normality. So H plus ion is equal to 2 into 10 power minus 2 what we got here. This I have to multiply with valency factor. How many replaceable hydrogens are there? 2. So H plus ion concentration will be 4 into 10 power minus 2. Now to this we apply pH. Now apply pH, student, minus log of 4 into 10 power minus 2. This is in the form of log A into B, log A power n form. So how I expand? Minus log 4 minus 2 log 10 can I write, no? Understood how I elaborated? Minus log 4, log A into B, log A power n form. Log 4 minus 2 log 10. This what I can write, see, this I can write here. Minus, what is the value of log 4 you have to know? 0.6020, double of log 2. 0.6020 minus 2 into log 10 value is 1. So 2 into 1. Now this minus 2 when I bring outside it comes to plus 2. So 2 minus 0.6 roughly. So from 2.6 when you subtract how much you get? 2 minus roughly 0.6 you take 1.4. So final answer will be 1.4. So this is the pH for as it is below 3, no? Since it is strong acid, the pH value will be below 3. So this is how we are finding pH. Understood? So what we converted, this mass volume we brought in terms of molarity. After bringing molarity, you have to multiply with the number of replaceable hydrogen, because there are 2 hydrogens are there. We got only for 1 mole. If 1 mole is 2 into 10 power minus 2, for 2 moles what should be the concentration? 4 into 10 power minus 2. For that we apply pH. Then students should know log A into B, log A power n form. You have to expand that. And the value of log 4 you have to remember. 0.6020 minus log 10 value is 1. So minus of minus comes plus. So 2 minus 0.6 comes how much? 1.4. This will be the answer. So today we stop here, and tomorrow we continue with strong base. Then we go into organic chemistry. By 15th date, we will complete the bridge course. As you know, the schedule being given up to 15th of this month. So today is 12th, 13th, 14th, 15th. The rest of the 3 days we complete organic chemistry. By that total bridge course will be completed. Thereafter we start with topics. We go into the next real topics of first year. Okay students, bye. I am ending the session. Wish you all the best. Bye.